Okay. Just want to verify the stream working. Alright. So there is I think there is okay. Alright, this is going well. Alright, welcome back. Today's what? Day 38. Um about 60, how many days? 62 more days to go. Yeah. Alright, so I've not even done half of the days. Anyway, I am going to solve some questions today. Today's session is going to be pretty fast because I'd actually spent time trying to solve this question and get a good understanding of them. Somebody said, "Can you share your LinkedCode profile?" Oh yeah, sure. I mean, this is I don't know how to share it, but hey, so this is my name on LeetCode. I think Wilfred Akpe 3. So I'll just put this in the comment section. Um, Maybe I should update my profile picture as well. I'll do that now so that it's easy to find me. Yeah. So let's see. I'll just choose an image and I'll add the picture I used on my thumbnail for it. So it's easy to find me on LeetCode. Alright. So how do I do that? I didn't start. I started on day one, which was um 38 days ago, right? So I've been studying consistently since then. So yeah, I'm sure you've been coding. Have you been doing Let's Code for a while now? Okay, so there's no response yet. Let me just go ahead and upload my new picture. I think so where do I get this? I had the picture somewhere. If I don't find I just want to use it the same picture so that I'm easily recognized. Uh yeah. Yeah. Thanks. Okay. Let's see where I can put this. So I'll save this here. Hopefully the image is not too big because I took it with a phone and phone images are just like really large. So let's see if it works. Oh, it did work. So let's save. Uploading. Oh, last 5 days. Okay, good. That's very good. Um, right. We are basically on the same journey. So yeah. Okay, so I've uploaded a picture on my Leets code, so you can see I have my thumbnail picture here, so you can use this um to locate me. I don't know if you follow people on LeetCode. Uh, all I know LeetCode can do is to solve questions. Uh, all right, so let's get on with this. I will just okay. Let me delete this part. Yeah, I don't need this anymore. All right. Let's solve some questions, right? I was going to solve the three sum question, but I decided not to do that and start with this one because of how funny this question actually is, and you won't believe this. I actually spent about I don't know, it's not up to an hour, but like this question is just so the implementation is so simple that you will not even believe. Okay, at least I've not even tested my my brute force code here, but I know for sure there was something simple about this question. As you can see, the acceptance rate is almost it's very huge, 1.8 million to 1.4 million, which is really good, right? So, and here is one. Uh, so I saw a comment in the discussion that really helped me understand exactly where I was going in the direction in which I'm supposed to go in order for me to solve this question. So let's read the question again. Right. So the question says delete a node in a linked list. Right. Delete node in a linked list. There is a singly linked list head, and we want to delete a node in it. You are giving the node to be deleted, which is this node. You will not be given access to the first node of the head, right? All the values in the linked list are unique, and it is guaranteed that the given node is not the last node in the linked list. Delete the given node. Note, by deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the linked list should decrease by 1. All the values before node should be in the same order, right? All the values after node should be in the same order as well. Basically, we are going to remove a node from a linked list without having access to the head of the node. So custom testing: for the input, you should provide the entire linked list head and the node to be given node, right? So node should not be the last node of the linked list and should be an actual node in the linked list. We will build the linked list and pass the node to your function. All right. Okay, so that's good. The output will be the entire list after calling your function. All right. So, as usual, I am going to make a representation. I usually use my board to actually explain stuff to myself, and it's just good, right? So let's say, um, here I'll just take this, right? Come here. Okay. Okay. So we are given a node, right? And we want to delete that node and return uh, the linked list. I mean, the node after it, right? Um, so here is our input, and we want to delete node at position 1. Okay. Right. You are giving the third node with the value 1. Okay, the third node with the value 1. Oh, okay. Oh, right. So the linked list should become 4, 5, 9 after calling your function. Okay. Um, so there are some constraints here. So the number of nodes in the given list is in the range of 2 all the way to 1,000. The value of each node in the list is unique. we have node.value is between negative 1000 all the way to 1000. So let's say right. So this, there is a comment here that really, resonated with this question so much. But I'm not sure if I should show the comment yet. But let me just, yeah, I think I should show it. So here's what the comment says: how to become another person in the world. 2 step. 1, change your appearance to whom you want to be, and 2, kill that person. I mean, this is not a violent thing, but like it's like a joke to actually explain, what this question is really about. And yeah, so if you think about it, right, if you think about the world would have been our linked list, but we are told to change one item, to delete one item in the linked list, right? So we are basically saying, okay, when you just get one person and eliminate the person, I'm not going to use kill, but like just think of it that way, and it actually makes sense, right? So let's go ahead and understand what the question is about. Where's my pen? Okay, so this is our linked list, right? And we are given a node. So a node to delete, right? So wait, is this the node we are deleting? So node, okay. Oh, I copied this. Okay, I was looking at this one instead. All right. So this is what. So we are given 5, right? This is the node we are supposed to delete in the linked list. But instead of giving us this linked list, right, we are given this node, meaning, automatically, right, we'll start from here. So we'll have something like this. Here we'll have 5, 1, and then 9. Now, how do we delete this linked? How do we delete this 5, this node, and still have 1, 9 remaining? And I'm not sure if 9 is the last item in the linked list, but let's just assume that. So we'll have none here. Okay, for us to do this, it's just going to be one operation. Now we know a linked list is made up of nodes, right? And each node, right? Each node is a class, right? Or an instance of a node class, which is made up of a value, right? A value and the next, right? So when we are given a node, right, to delete from our linked list, let's say this node is going to be 5, and the next value here is the node where you know 1 is, right? And 1 will also point at 9 and so on. So let me just represent it this way. Now to delete this 5 here, right, to delete this 5 from our linked list just by having the value of the node, right, we need to first of all set this value here, right, to the value of this node, right? So this node here is no longer going to be 5, right? The value of this node has to be changed this time around. So we change the value of this node the value, which is why this person's this resonated so well. So we are actually changing the appearance of the node, right? Changing the value of the node to the next value, right? So we change the value here to the next value here. So node where 5 is, right? I'll say node dot value should be equal to what? To this node here, right? Where 1 is. And then we will then take the next value of this node dot next, right, and set it to the next value of this. So next dot next, or node, let me just put it this way, node here, node where one is dot next. Now get node where one is. It's simply the next value of where this node is, right? And that's all we need to do. That's all we need to do. So, I mean, first of all, I was actually thinking, I would have to start from the head, right? I mean, a typical way to do this is to start from the head, traverse the head all the way to a certain point, and then change the value at that point, right? But this time around, we are not giving a head. Uh, we are not giving a head. So we just only need to change the value at a certain point. And yeah, so that's how we are going to do it, which is why I started with this question first. Because um, again, I have not tested my assumptions, so I will just go ahead and implement this. So let me create a file. I'll call this file. Where? Oh, sorry, I'm not showing it on the other screen. Crikey. So let me call this. What's the name of the question again? I think it's delete node. I'm not sure why my computer is lagging. I probably have too many programs opened. So, but yeah, today is going to be a quick one. So I'll make sure my computer doesn't go off before then. So let's create a, you know. So this is going to be delete node. What's the question? Lead dash. I've tried to put up with a convention. Uh, oh, okay. Oh, hi. I have sent a collection. Yes. So that's so. Yeah. Let's try to change certain things here. Okay, I will check LinkedIn later and accept your connection. I will accept your connection later on, and yeah. So let me just finish this stream today. Okay. Where was I? I forgot. Okay, so LinkedIn. This is going to be 237. Delete node in a linked list. So 237. Leads 2337. Right. I'll call this delete node. Right. Uh come on. Delete node in linked lists. So I'll call it that. And again, so we'll say here we'll need a node. So we'll pass. I'll just copy this. And here's what I need to do. So take this, take this, take this. So our node is just simply going to be an instance of a node, right? And we know the node has a head and the node has a value, right? And the next. So let me just shift this to this side. You can see this here has a value and a next um a next property. So I'm just going to do it this way. So I'll create so the first thing I need to do, I need to get that node, right? Probably get a copy of the node. So I'll say copy, or just call this node copy. Sorry, copy like this, and I'll set this to the node, right? Now we want our current node, so this node here that we've been given dot value to be equal to the its next value. So I'll just going to say node copy dot next right, dot value. Sorry, node copy the next dot value, and then you just do node dot next, right, should be equal. I don't think we even need the, I mean, we should. Nah, we don't even need this. So I can just say node like this, right, and say node dot next dot next. Okay, we are not supposed to return anything, right? So I will just copy this and put it here. So let's run this. There is something. What's happening? List node has no attributes val. What? Wait. I mean, it's a list node, so why is it saying there is no value? Oh, sorry. It's not value. It's val. Tada. And that's it. So this is just an operation of O of 1 time complexity. Not really. From the description, it appears you need to know the head. Yeah, so I also thought this too. From the description, it appears you need to know the head of the linked list in order to traverse it, then delete. But in reality, you are given a node to delete. So you just need to copy the node value and pointer from the next node. Yeah. So, and yeah, this is all you need to do, right? So I'm just going to submit this. So this worked just fine, right? And we are good to go. So I'm just going to move on to the next question, which I had already solved. But this question is actually okay. So there's a new question in this part here. So what's the question? Threesome. Threesome is a very, very tricky question, and I know this question will take me a lot of time to explain because I actually spent a lot of time trying to understand it as well. But it is just a combination of, if you know about the two sum question, right? Two sum question, then you will know this question is actually kind of similar to it. So let's try and understand this question first of all. So given an integer array norms, return all the triplets, right? Norms I, norms j, norms at k, such that I is not equal to j, I is not equal to k, and and j is not equal to k. Norms plus norms at I plus norms at j plus norms at k is going to be equal to 0. Notice that the solution set must not contain duplicate triplets. So here's what we have. We are given an input, right? And then we return the triplets such that their sum is equal to 0, right? So if you add -1 to -1, you will get -2. -2 plus 2 is going to be equal to 0. And the same thing happens here, right? So, yeah, that's really what it is. So norms at 0, which is this -1 here, plus negative. nums are 2, right? So 0, 1, 2. Yeah, this one is this here. And then, so looking at this, it means we will need to, sort the array, right? Because what we are looking for, well, when the question says, at least one thing I've noticed so far, when we are asked to get distinct indexes, right, um, from a certain array, it means we're not trying to repeat items, right? So when we sort the array, when we sort the array, we would then know, the position of each item in that array, right? In an incremental order, so that we don't actually do the mistake to, include an item twice. Now, what we need to do first of all, we'll sort this array, right? And then we'll apply. So when you look at the hints, right? So essentially we need to find three numbers such that s, y, and z, right, they add up to a given value. We fix one of the values, say number x, with the left. Sorry, we fix one of if we fix one of the values, say x, we are left with two sum problem at hand. Exactly. So, and the two sum problem was done with how do you call it, sorted arrays, right? So that's what the two sum problem is. So if we fix one item, in this case, this item, this number that we fix here, will become our target. So we need to find two numbers such that when we add them together, they become the opposite of our target, right? So the opposite, why are we using the opposite? So let's say, for instance, let me just delete this. Where did I drop the stylus? Okay. So we have our array, right? So let's copy this value here. Sorry. Blue or white? White is good. Okay, so here's what we need to do. We'll first of all fix a value, right? We'll fix one value as our target. So let me just assume that this array is sorted, right? Although it is not, but I just want to use the first three the first four values, right? Because we want a triplet. And the triplet is going to be three values, right? When added together, you know what? Let me just sort the array, right? So the sorted form of this nums should be equal to, so -4 will come first. What else? Then -1, 0, 1, and then 2, right? So this will be our sorted array. Now we want to do so we want to take one item and fix it, because we want a sum of three values, right? So the sum of the three values should be equal to 0. So when we do x plus y plus z, right, it should be equal to 0. But in the case where we choose to get a fixed value, right, let's say we are looking for x should be equal to -z -y, right? And the reason why we need to do it this way is because when we add these two values again, we should be able to get 0 at the end of the day. So again, x, or -x, right, should be equal to z plus y, right? This is also the same thing. So which means we need to first take this value, right? If we took 4 as our target, right, if we took -4, which is going to be our target, I'll call this T. Then we are left with a two-sum problem at hand, which means we want two values such that when we add them together, it will be equal to this value here, right? And when we look through this array, so when we start from this point, right, we can't start from the same value again. When we start from this point, we'll look through the array and we'll just realize there is no two numbers that add up to -4, right? Because we want to get -4. Just remember that we want to get -4 and not 4, right? So -1 here, and we just iterate through the array. But when we get to this point, let me just show you what happens when we get to this. Let me use an example from this place. Which example did I even use? So I'll say, okay, we have -1, -1, and 2. So why is -1, -1, and 2 the correct triplet, or a good triplet for this question? So if we have -1 as our start, right, our target is -1. Let's say this -1 here. So we want to perform some calculation, right, to get this particular value, but opposite of it. So here's what we need to do. We first of all need to take the target. So I'll set my target to -1, right? This will be my target. And I'll look through this array, right, and find two values such that when I add them together, their total is going to be equal to target. But that is really not going to happen, right? Because target is negative already, and we want negative of target, so which is going to be positive. And for us to get two values at the same time, there are two ways we could do that. We could either use two pointers and put these pointers at the end of the sorted array, and at this position here, right, or here. Or another way to do it is to basically create a dictionary and put every unique value, or every remaining value, every unique value in this remainder here in the dictionary, right? So we are going to have I'll call this map, right, because this is just a hash map or hash set, even though I've not done hash map before. But like that's a conversion for data structures and algorithms. So we have our set here, or our map here, and we'll put every unique values in it. So we'll have -1 at index 1, index 2, -0. Oh, sorry, there's no -0. 0 at index 3, 1 at index 1, 1 at index 4, and 2 at index 5, right? So this is what our map is going to look like. And then what we need to do is, hope I'm okay. And then what we need to do is, we'll first of all take these targets, right, and say, okay, we know for us to get the second value, let's say we are iterating through this, the remaining value after the target, one at a time, right? So we are starting from this point here. I'll just call this I is going to be equal to 1. So when we are at this position, right, how do we get the third value? Because the second value could be any value in this array, but the third value would be a value in this our map that we created. So how do we get that value? We simply need to say, okay, to get this value, right, since we know target, negative target is going to be equal to z plus y, right? To get z now, to get z, right, which is our third value, to get z, we simply need to what? To minus target minus y, right? Or in other words, we simply need to do target plus y, right? And everything should be put the minus in front, right? Now the value we get here, right, has to be in our dictionary, right? And once we find that value in the dictionary, it means we've gotten our third value for us to create the how do you call it, the triplets that we are looking for, right? So yeah, so these are our triplets. And so we can only show this in code, right, for us to really understand it. So I'm just going to come here. I'll close this since I've solved it already. So here, this is the code for it, and I'll explain what this code does. So I'll copy this and start here. So what's the name of this question? 3 sum 15. I'll put it in pointers. Yeah. Well, what's the topic? Yeah, 2 pointers and sorting. So let me come here. 3 sum question. So what's the number again? LeetCODE common. Crikey. 15. So this number 15. I'll say leet dash 15 dash this 3 sum. Oh, that sounded weird. Okay, so 3 sum, and yeah, so I'll just put this here. What did I copy? Oh god. Alright, so let me copy everything here and explain, because I am running out of time. Okay. So here's what we are doing, right? There's no okay, no question. Alright, so here's what we are doing. We first of all started, we'll have our triplet at the end of the day. So I created a triplet, and I sorted the array, right? So the array is sorted as well. Now we start with the first, or the outer loop, right? The outer loop is simply going to so there is a check here. Now this check is for duplicates. When we sort the array, there is a chance we'll have duplicates in the array, right? And in this case, let me just say set this. I'll say print. Okay, so solution is equal to this solution here. Create an instance of this solution, sorry, and I'll print solution dot 3 sum and solution dot 3 sum. Just take this and put it here. Okay, this will print our triplets, right? But let's print the sorted array first. So print sort nums, right? Okay, so when we print nums, you can see we have the array like this. So we have -4, -1, -1, 0. Now you can see we have -1 twice. We can set our target, right? Because we calculate the 3 sum by choosing a target, and then we'll find the next 2 values, right? So if we chose our target as 1 before previously, we don't need to set our target to 1 again, because that means we'll have duplicated values, right? We'll have 1 and 1 here, right? Which is going to be -2, and then we'll have 0, 1. We'll calculate this and end up with triplets that we've already seen before. So instead of us doing this way, after sorting the array, we simply ignore duplicated targets, right? Which is going to be the start of our triplet, one of the values, I mean. So the next thing to do is to run an inner loop. Now this is where we perform the 2 sum operation, right? And I've done this before, where I did the 2 sum calculation. I'm not sure where it is. This 2 sum 2, I did a 2 sum problem where I think is in array to some. Yeah. So here we created a map and set every value in that uh array into the map, right? So we'll have a unique version of every character in the array or every integer in the array in our map. Now then we will now choose this is bad naming convention, and I'm not sure why I did this, but basically what we are doing here is we are checking if the target, right, minus the current value in our iteration is equal to the ny, which is, I don't know why I called it ny, but like this is going to be the result of our, this is going to be the second value to which when we add n at I, we'll get the value of the target, right? So if this value is in the map and the current index of that value is not the same as I, then we'll know we found a match, we found a sum, which is what we did here, right? And the same thing happens here, but slightly differently, right? Because this time around we want 3 values, and we know our target has to be dynamic. It changes every time for every value in the sorted array. So here's what we need to do. We run an inner loop, right, from 1 plus the index. So if we started at -4, we need to continue the sum, finding the 2 sum in the rest of the array, which is going to start from -1. And of course, when we're at this point, right, so like I said, the third value is going to be the negative, it's going to be the opposite of the target plus the current sum, right, the current number in this iteration. So now at this point we've not started building our dictionary, right, or our map yet, because again we are trying to avoid duplicates, right? So we build the map only at the end after checking if there is a third value in the map, right? If there is no third value, then we begin to build our map slowly. Otherwise we would have had a different loop here that will build the map, but at the end of the day we'll get a value that we've already seen before, and then we'll set it inside our map, which is really wrong, right? We'll set it inside our triplet. So we need to create a triplet that we found in this iteration, right? So we might find a triplet at some point, right? Now this triplet is going to be sorted. This is a built-in function. I did do this myself. So basically it will sort every value in this array, right? And now this is the triplet we found so far. Now if the triplet already exists, because we don't want to have duplicated triplets, if the triplet already exists in our local triplet, right, which is this place, we define this here because every time we want to return a new triplet, right? So if the triplet is already in our local triplet, we don't add it. Well, if it's not, we add it to our local triplet, right? And we continue the iteration and so on. So until then, we begin to add build up our map, right? We begin to build up our map, begin to add a new value to it. Now what's the reason why I did this? So triplets.extend local triplet, instead of us having, if we added, let me just print the local triplet at this point. Print local triplets, right? So when you look at this is the local triplet. So this one here, the first iteration we didn't have any triplets. So in the second iteration we had a triplet, right? So this is our triplet here from this 3 sum here. So what the extend function does is it unpacks every value, right? It unpacks it into a new array, right? Otherwise, if we did append, right, append local triplets, then we'll no longer have an array of array, right? We'll have 3 nested the nesting of our results will be inside 3 arrays. So let me just run this now. You can see instead of having just our result, right, we are adding every value to it. I'm coming, let me see. So I'm printing local triplets, and our result is what? Our result should be this. So come again, print local triplets. I'm printing the solution, return triplets, right? Instead of returning, a list of a list inside a list, right? We are returning a list, then a list inside a list, which is really wrong. So we need to use the extend function to unpack our array, right? So as you can see, we have here we have this closing, right? This is another one. So three level, 1, 2, and 3, and we're even adding empty arrays to it, which is not what we are supposed to be doing. So the local triplet gets calculated every time, but we need to extend, right? So we need to extend to add our actual values to it, which is this, right? So what we have here. All right. I mean, this solution is not the best of solutions, right? It actually passed the test cases, but the good thing about this is this was a solution that came from planning, right? You can see it's 22%, which is really low. Even the memory, I expected this for the memory, because I kept creating new arrays each time, which is what I'm supposed to do, right? But I'll, I haven't had a look at any other solutions yet, but I'm sure there are a lot of best solutions out there. But for the sake of implementing one solution and see how it works, this will give you an understanding of this. I'm not saying looking at solutions is bad. It's actually going to speed up the process and you understanding what exactly the solution is about. But doing it this way will also will also remind you of what you did wrong, right? In order for you to improve on it. Okay, so I mean, after this call, when I have time, I'll look at some other solution, some other implementation to improve this solution. Okay, so that's it for tonight, and I'll see you tomorrow.